All right. I believe we've let everyone in. All right, well, keep an eye on the participants as we get started. So let's see. All right, everyone. Welcome to Beyond the Scan. We're excited to be hosting this live webinar focusing on real projects that go beyond just laser scanning. While a few more people are joining, I do want to mention that Beyond the Scan will be live the last Thursday of each month at 11 a.m. Eastern. We send out the registration links on LinkedIn and over email about 2 weeks ahead of time. Anyone can register, so feel free to share those around. I'm Kyle Cooper, your host, joined by both principals of ASBIL, Jason Schwartz and Jason Atkins. Today, we're going to cover where scanning delivers real value, when scanning does and does not make sense, what we mean by beyond the scan, and then we'll jump into a few projects to review. At the end, we will leave time for a Q&A session. If you do have a question, put it in the chat, and I'll do my best to read it off either during the projects or during the Q&A section. If we're ready, let's get started. Jason.
Great. Thank you, Kyle. I guess before we get into the details, I think the simplest way to look at scanning is this. Its real value is not just capturing a space. It's helping teams make better decisions with better information. And so let's jump into these little slides. So reducing risk in complex environments. In complex facilities, uncertainty is usually what gets you. There are hidden clashes, things that don't show up clearly in old drawings, and a lot of field assumptions that can come back to bite you later. Scanning takes most of that uncertainty off the table by giving the team a much clearer picture of what's actually there. But improving retrofit and tie-in accuracy. This is a big one, especially on retrofit work. When you're tying into existing conditions, there's not a lot of room for interpretation. If something is off even a little, it can create a pretty expensive chain reaction. Scanning gives you a much stronger level of confidence that what you're designing or fabricating is actually going to fit when it shows up on site. Maintaining reliable, up-to-date documentation. Another major benefit is documentation. A lot of facilities are working from drawings that were right at one point, maybe several projects ago. Scanning gives you a current reliable baseline, and that helps not just on your current project, but on the next one also. Accelerating project execution timelines. When the team has better information from the start, things tend to move faster. You cut down on repeat site visits, you reduce back and forth during coordination, and avoid some of those late surprises that can slow everything down. So while scanning doesn't solve every problem, it definitely helps projects move with a lot more confidence. So really the theme here is pretty straightforward. Better information up front leads to fewer surprises later. You want to advance that slide for me, Kyle? Thank you. There we go. When scanning makes sense. Yep, perfect. So the next question is, when does scanning really make sense? And the easiest way to think about that is in two buckets, the project itself and the environment you're working in. So let's start with the project conditions or states. Shutdowns, outages. If you're working in a shutdown or outage window, the schedule is tight, the tolerance for error is basically zero. There's not a lot of time to figure things out in the field. That's where having accurate scan data ahead of time can be incredibly valuable. Retrofits and tie-ins. Retrofits and tie-ins are another strong fit because you're not starting with a blank sheet of paper. You're connecting into something that already exists, and it has to work. Scanning takes most of that guesswork out of there. Capital upgrades and expansions. For larger capital projects or expansions, stakes are usually higher. There are more teams involved, and coordination gets more complicated. The more complexity you have, the more useful it is to start with accurate existing conditions. Equipment installation, fabrication. When equipment's being installed or parts are being fabricated off-site, precision matters. You really want to know what's being built is going to match the field conditions. That's another place where scanning can save a lot of pain later on. So let's review some of the environment conditions or states that contribute. Congested or complex facilities. It seems like everyone is a congested facility these days. Scanning makes a lot of sense in congested or complex spaces. Those are usually the areas where field conditions are hardest to interpret and assumptions can get risky real fast. Poor or outdated documentation. It also makes sense when the available documentation is weak, outdated, or just incomplete, which honestly is pretty common in industry. In those cases, scanning helps establish a much more dependable starting point for the project. Tight tolerances, we have projects with tight tolerances where being off by even a small amount becomes a real issue. In those environments, accuracy matters a lot, and that's where scan data really earns its keep. Active operating plants, my favorite. Active plants are another great example. Access is limited, site's busy, and nobody wants repeated field visits if they can avoid them. Scanning lets you capture a lot of information efficiently with less disruption to operations. So if you put all that together, scanning tends to deliver the most value when you have a complex project happening in a complex environment. And that's usually where the return is the clearest. And really that kind of leads into the headline idea of this webinar. Scanning gives you accurate site data at the start. The bigger opportunity is what you do with that information across the full project lifecycle. And with that, I will turn it over to you, Mr. Atkins.
Right. So before Jason jumps into sharing some project demo, just want to talk about what beyond the scan actually means. So beyond the scan means that the scan is not the end product, it's actually the starting point. So we'll start with 3D scanning, and every retrofit project should start with a laser scanning. This will be the true capture of reality, the true as is conditions right now on site. So our goal in doing this is help you make the unknowns known and not rely on old or outdated drawings. Since most people are not working in the point cloud, the next step is, after capture, is creating a usable 3D model. In this 3D model, we can output this in just about any file format, and also level of detail. Next thing would be moving into 3D concept and design. So once we have the 3D model, this becomes your design background. So this lets the teams develop concepts and designs in the context of the as-is environment, what's actually at the facility. The other benefit of this is it's perfect for team and group collaboration. So now you can bring in safety and maintenance and operations, facility management. So now you're able to get that early buy-in from multiple groups, and there's no need for the team members to be able to read drawings. They can easily review this design in this 3D space. And so, like I said, that's really beneficial to bring in operations, maintenance, the guys who are going to have to live with this design after it's implemented. Then we move into 2D drawing creation. So since 3D modeling does not replace the 2D as of yet, but what it does is deliver better 2D deliverables. So from the 3D, we're able to pull 2D drawings, and that's from general arrangements to elevation, fab drawings, site plans, ISOs, P&IDs, and even IFC packages. I wanted to throw fabrication inspection in here because this is one more opportunity. And you can go through the first portion that we've just covered. And then those parts actually have to be fabricated and created. So this is an opportunity to introduce risk into your project. So we've got the design, goes to the fab shop, and if it's not fabricated correctly, then we're going to have fit up issues at install. So just as we're scanning at the beginning of the project and capturing the as is, we're doing the same thing in the fab shop. Scan techs go to the site, scan the fabricated equipment, overlay the point cloud over the design model. Now we're able to see any deviation or anything that should be corrected prior to shipping to the site for install. Then we move into demo and install support. So over the years, we've sat in a lot of meetings and project review and installation planning. And, it seems like everybody's in agreement as to what we're going to do when we get in the field. And you get everyone shaking their heads like they understand what we're doing. But then we get to the field and all these problems arise. And so what we realized is, not everybody on the team may be able to go from 2D into construction. And so what we started doing was we would take the 3D model and think of, we've got the design model and we're going to look at demo. So if we have a demo portion of the project, you're going to see the 3D model disassembled, screenshots. Step 1, we're going to remove equipment. Step 2, step 3, and so on. So we demo in 3D, and then we rebuild in 3D. So that's not meant to replace the 2D drawings for installation packages. That's really just meant to complement those drawings. Next step would be construction validation. So this is scanning during construction and installation. And there's a couple of reasons to do this. One, are things being installed as shown in the design package? 2 would be to capture all of these areas that may not be visible once the equipment or other equipment or systems are installed. And then also would be to document areas such as confined space or areas that we will not be able to enter, or equipment that won't be visible during normal operations. So you're able to use that for outage work, planning work, and showing what the inside of that space would look like. The other thing would be like MEP, anything that's behind walls, behind ceilings, or covered up after construction is complete. Last thing we look at is, now we've worked through this progression, is now I want to update that as-built modeling and provide that as-built model. So now that we've got everything scanned during construction validation, we're able to update the 3D model to reflect exactly what was constructed. And from the 3D, now you're able to produce all of the 2D drawings. So now you kind of take that red line process away, and now you have trusted information that you're ready to use for, if you have another project in that area, you're ready to immediately start planning and go to work because you have trusted information. But this can also be used for day-to-day operations, training, planning, operations, maintenance, all of these different areas. You can apply this 3D data to those daily operations in many ways. And just want to throw this in is, looking at this workflow, one thing I always tell clients, and we've proven this many times over the years, and I always say that, this is a free service. Yes, you're going to pay for this service, but if you follow the workflow, this workflow pays for itself many times over. If you catch one costly error, that potentially pays for this entire process. After catching the first, now you think about eliminating the second, the third, the fourth, the fifth error. Now you're seeing huge returns from following this workflow. I'll turn it back to you, Jason.
All right, sounds good. Kyle, I'm going to grab the screen.
Yep, go ahead.
Works for you.
And as you're pulling that up for anyone on the call, we do have a Q&A chat section. So if you have a question, throw it in there. If it's project related, we'll pause and answer your questions in case we want to show the model. If it's anything else, other questions, we'll save those for the Q&A live session right after the project review.
Perfect. Screen showing up okay?
Yep.
Yeah, good. All right. Okay, I've got a few projects that I queued up to walk you guys through today and see if it prompts any questions. You know what? One thing I was thinking about, we never do talk about what laser scanning is. We talk about beyond the scan, but maybe there's some people on the call that aren't as familiar with laser scanning as some of the others. So I'll bend you here for a couple minutes and we'll talk about what laser scanning is. And basically all we're doing is shooting a laser beam at a fixed static object, and it's going to bounce off that object and it's going to come back to the thing that generated the laser beam or the laser pulse. It's going to measure how fast it came back, and that's how it knows where that point is. So when you look at my screen here, I'm just looking at, I mean, in this field of view, there's probably around 20 to 30 million measurements that we can see. If we kind of zoom in, you start to see them look like dots, and I'm not sure if that renders so well for you guys looking at it, but here we zoom in way in and you can start to see the dots stacked up. And those dots, when we stack enough dots together, they start to look like things like pipes and angle iron and C-channel and structural members and all kinds of other stuff. So you can even see wires and hoses, and that's what laser scanning is. So we're taking, we typically take about 43 to 46 million points every time we do it. We spin the scanner around. So the scanner collects data around 2 million points a second. So we're able to capture a lot of measurements per second, per hour, per day, per man that's out there. And that's what we're stitching together. So when we take a scan, these little bubbles that you see kind of floating around my screen, these are actual locations where the scanner was placed on a tripod, and then it spun around and collected that data, and then we moved it over. And you can see we don't move our scanners very far when we're collecting data in complex areas, because we're really trying to capture all that data at a really rich level. Whenever I used to train new scan techs, I told them I'm basically handing you a giant paint sprayer. So go and spray everything you can see. And when you can't spray any more paint, move over a little bit and spray some more so you can get the backside. So hopefully that gives you some concept, if you weren't familiar with laser scanning, of what we're doing to capture that amount of data. This project that we're looking at here probably has around 3.5 billion measurements maybe that make up this project. It's under 100 scans and was something we would consider to be a really small project for us, but that, not that it matters, but I'm just on our scale of projects, it's kind of on the smaller side. So this is what scan data looks like. It's not the friendliest thing to look at if you don't look at it every day. So we usually share our data with our clients in something that's called real views. And these are more of a 3D view, not 3D view, but an actual panoramic view of what you guys are looking at. So now we're able to kind of poke around and look around inside the plant, and we can hop from all these little different bubbles from one bubble to another. So I'm going to hop into this project, and then I'll kind of tell you guys, what this project is, what it was. This project started out with some end-of-year money that people had, and they needed to get it spent, and they ordered some equipment for their air compressor room, and maybe the due diligence that they usually do on their projects was not done for this one. So it turned out the equipment really wasn't going to fit up the way they thought it was going to fit into this room. They're very familiar with us. We've worked with them for a decade, and they said, we really think this is the right project with the right environment, right? The two buckets we talked about earlier today. And they said that we need you guys to come in here and scan. Get us a background of what's going on. We really weren't familiar with this area, so yeah, sure, we'll be there. Here you can kind of see some of those other scan locations in the background. So we come in and scan this compressor room, and it's pretty congested. the thing is, you can't really see what's going on up here. The lighting in these mechanical rooms is not great. And this is what, people think, well, what am I really going to see up there? Now it's time to shut off the color scan and look at what the laser actually saw. So that changes the game big time. Now we really see what's up there, and it is a mess. I'll say it's a mess. We'll say it's congested and complex, I guess, to use terms from the earlier slides. But now we understood what the problem was, because the floor to us was not very congested, like something we could deal with without any problem and find a place and a new home for the equipment to go. But what was killing them were all the lines that were running up there. And we can't even really see them all from this vantage point. We had to put the scanner up above and scan above the cable trays and above the lines. There was service running through this room that had been abandoned for over 20 years. There was service in this room that people didn't even know what it was. We found one line that's used like every 5 or 6 years when they do a boiler wash down, and they were getting ready to cut it out. And finally, someone had traced it back using the scanning and the modeling and said, do not cut that out. Yeah, we don't use it every day, but someone's going to be really upset in 3 years from now when we do want to wash down. So we were able to capture, all this equipment and service that was up in the ceiling. And, to follow on what Jason was talking about, this is what it reduces down to for us. And we get a 3D model and something that we can now work with. So, now we're looking at, we can look at it without craning our neck and getting a bad neck ache, jump down into the scene itself and really see what we're going to work with to make this job happen. Let's see if I can pop in here. I'll just go right to where we just were looking at the scan data. So when we were looking up and we saw all that, now we see it all in 3D. So now we can really see, like, what is it that we're going to have to route again? Or what are we going to have to route around to get this stuff in? Where can we put the new equipment? This model has the old equipment already demoed out. It's pretty congested otherwise. We started scraping out the old equipment to say, where's the new stuff going to fit? And, as Jason had talked about, when you're able to share the 3D view with people beyond engineering, beyond capital, beyond maintenance, and really get to like the operators also and say, hey, what do you think about this? They started making additions. They wanted new manifolds. There was valve trains that they wanted to replace. They wanted valves moved where they were accessible. We can all have that conversation when we're not looking at it in 2D in a plan view or maybe 1 or 2 elevations. But when we can actually walk around the actual site and look, it's a lot richer experience for all the team members combined. And that's really where the magic starts to happen with these jobs. So see if I can pop you in. I'll show you. Let's see, we've got that queued up. So here's the new equipment coming into this scene. And this was the equipment that we were tasked to place. Was go find a home for this stuff so we can get it in there. And then it has to fit inside the environment that we were just looking at and just got kicked out of. But there we go. And that's the iterative process of placing that stuff in there. Instead of just taking the best guess at it, let's see, we'll just kind of jump into first person. We can kind of walk around. How does this stuff fit in here? What does the new pipe look like? There's the new manifold that they wanted installed with valves that were operable from floor level, and you didn't have to go get a step ladder or something else to access those valves. There's a lot of cleanup that occurred up in the ceiling itself. Some of the mains were reworked to simplify things and just clean up 40 years of additions and of taps and things like that were going on. And eventually all this reduces down to an actual drawing set. So the drawing set has the typical stuff that we see in a drawing set, the things that you guys would send out for bid or that you might be bidding on if you're a contractor. It's got plan views, elevation views. Our packages go all the way to spool drawings. So all the stuff was prefabbed offsite. It was all brought in and it all bolts up. And it bolts up because we know how it fits together. And we know that we're not going to be bothered by something in the way. We already know where it is. We've already planned for it. We've already shifted it over 6 inches to the west so that it's going to miss the hangar for the existing water line that goes through there. So all that stuff is thought through, and that's what's happening beyond the scan. So it's not just coming in to get the existing conditions, but it's applying those existing conditions and being able to use that amount of dimensional information that really wasn't available to us and we're engineers. So I mean, this stuff really wasn't available to us before maybe 2015. At least it wasn't available to us. It was available for some really complex projects, but the cost was so prohibitive that it didn't really make it into a lot of people's workflow. Now it's available for everybody's workflow. We don't touch an engineering job in our mechanical engineering house without doing laser scanning and modeling beforehand. We've tried a couple of them over the years, and all those risks that I talked about come right back into the job. So it's kind of like we know better, so we're not going to do it anymore. And if the client refuses to use laser scanning, it's probably a job we didn't want anyway. So we kind of pass on that one. So Kyle, that's sort of the end of the dryer project. I'll kind of switch gears and show you guys like 3 more projects. It won't be as long or as intensive. All of the things that I showed you guys, I'm just running live on the machine right now, so we can circle back if anybody has questions, want to see things about them. Populate the Q&A box and we can address them. Oh, I can see the thing. So I'm going to answer that one at the end because it is a great general question. So let me switch gears. I'll show you another project that started with scanning. I'm showing you a couple different tools. So the first scan job I showed you guys was in Recap, and that's a free viewer that runs on people's desktops. It's an Autodesk product. This version I have is not the free version, but it's only because I combined and my team makes these things. But the version that you guys would use to interact or that your clients would use to interact is a free desktop version. Most large companies already have it approved through IT. It's pretty easy to digest and get it on the machine. Autodesk also has a way to view these online. So now we're kind of looking at a point cloud online, and this is of a big crusher house tower at a power plant. So this is a coal handling system at a power plant, and we're looking at data. Again, not the friendliest way to look at data unless you guys are living inside point clouds all the time. So same thing occurs here. There's real views we can go in and see. These are kind of those 360 views where we can look around and we can hop around the environment and see what's going on. Another job that fit a lot of the buckets that I talked about. It was a complex job. This might be the cleanest I've ever seen this area, and it's still pretty dirty. You guys kind of see what that looks like. When it's in operation, there's typically material falling from above because of leaks and things like that. Noise level around these 600 horsepower crushers is, 800 horsepower crushers is pretty oppressive. So again, not a place that you want to send a whole team in for 3 or 4 days to pull tape measures and conceptualize what we're going to do. We're able to capture this entire site, probably 3 or 4 man days with a crew of 2 or 3 people. And we're in and out really fast. That reduces our exposure from a safety standpoint. We have less people there. The people that we are sending are highly qualified. They work in that environment every day, or they work in this type of environment every day, rather than the guy that works in the office 98% of the time coming out on site and maybe not being as safety aware as techs who do this every day and are qualified to do it. So for us, that's a huge risk reduction in not bringing a team of maybe 7 or 8 semi-qualified engineers when we can bring 2 or 3 very qualified technicians. This project was a really complex design to try to figure out how to get material to flow from one side to another and to make all this work. So we took all that scan data and we basically reduced it down to, let's see if I can just grab this. Where's my as-built? To that. So, there was a lot of scan data there. I mean, when you guys looked at that other scene, it pulls all the way out. I mean, I can see buildings and other things that are at the power plant. Those are distraction. I don't need the conveyors. I don't need this dust collector or precipitator, whatever it is. We want to just focus in on exactly what it is that we're after. And that's what this did. It kind of showed us our start and stop points for the process. We knew we were bringing coal in at the top here. It had to go through this machine right there, and it had to get down onto this conveyor down there. Now, there's a whole lot of other things that they wanted to accomplish. Of course, we're in anybody's facility, right? These should be exactly the same. Nope, not even the same manufacturer. So, we don't want to make those assumptions when we're in retrofit that, well, they're the same. So can't we just divide it down the middle and build half of it? No, absolutely not. So that was not going to work for us here. So this is what we ended up building is all of this had to fit into that space, and it had to fit without constraining the existing structural that was there. If it did, we had to rework the existing structural to make this all fit. So you can see some new structural members are in there. But to get all that to fit in there without any conflict and to make sure that where it starts at the very top, which is critical, we can't change the location of that bearing to where it actually ends down here. These are like sub inches. We're talking fractions of an inch is where I need to land, and it all has to be done right, and it has to be accurate. And it's a pretty complex fabrication. So now we're designing in a very complex environment. We're designing a complex system, and then we're asking a fabricator to fabricate this out of 3/8 inch stainless steel. So now we get into some of those other cards that Jason Atkins discussed, which is going and scanning these parts while they're at the fabricator. Now they can't assemble this whole thing. It's 85 feet tall, but we can scan every one of these sections, and we know how they're going to fit together with the gasket allowance that we know where we're going to be when we get to the bottom. And it's a powerful example. The job doesn't have to be this complicated. It could just be a skid that we're bringing in and making sure that the nozzles fit up where they're supposed to, making sure that the bolt holes are correct on a flange for a fan or something like that. So this is kind of the pinnacle of what we would leverage laser scan and 3D model for. But just imagine it distilled down to a project that you're working on. They're all the same steps, and they all reduce risk the same way. And whether that risk number is a $5 million risk number or a $50,000 risk number, it's still dollars that we could put to work somewhere else in a facility. So that's our crusher house. Kind of back off a little bit here. This is a light manufacturing facility. This is one of, let's see, this is plant 2. So there were 4 plants here that we were scanning, and these guys had come in, pretty new plant, and they just started dropping equipment from Germany on the floor, and sort of, this is where it'll fit. Yeah, just put it over there. Maybe it's got a center line and matches up with something else. Not really. So they really just didn't have any idea of where everything was in their facility. And they said, can you come in and basically blueprint the facility for us? Because we don't know where things are. We came into this building, the HVAC was already there. We don't know what's there. We don't know where the fire protection is. So this is one that, just doesn't look as complex as like a power plant. But they were getting ready to upgrade their lines. And they said, what we want to do is reorganize all this. The engineer that first laid this out got us up and running, but now we need to optimize this facility. We need to get these things in line. So now with this 3D model, they were able to do simulations with like material movement. And well, why does a fork truck always have to come here? And why can we only use a little fork truck to get in there? What's the things that we need to change? Are there areas where we could put some maybe roller conveyors that we don't have to use a fork truck? And could we automate and power those roller conveyors? So all these like great conversations start happening. And then they had built onto this thing, and not out of the 4 plants, it's like none of them had anything to do with each other. Like it just wasn't thought through. So giving them a 3D model of this whole thing allowed them to pick these objects up like matchbox cars and just move them around. So they were able to start twisting the equipment they had 90 degrees. Then they could see whether or not they had utilities that were accessible. And it just became a real powerful tool for them. And we kind of pulled out of it. Like it's not, that's not our specialty. If they needed help running like high energy pipe or something, which has nothing to do with them, we could have assisted. But we wanted to give them that base and that foundation. And they had the vision to see that having that type of information made them very powerful from the manufacturing engineering standpoint. So that was just a different flavor job. And then I'll kind of wrap on this one. I go on forever with this stuff. I love it. But there are times where we get asked to digitize an entire plant. So this is a pretty large power plant. It's in Florida, and this scan has around 10,000 scans to capture something like this, and it's not just the exteriors. I mean, you go in and the turbines are captured, the entire turbine building is captured in pretty high detail. We're looking at this on a web browser, so it's going to just kind of populate as we move through it. It's just caching in, but a lot of detail. And these guys were looking for a way to see the entire plant in 3D. They didn't trust the drawings. We were using this model to verify P&IDs for them. So we were verifying P&IDs in this area because the P&IDs, you could hold them up and you could stand in that area and they did not match. Valves had been added, some valves had been removed, some valves they don't even think got delivered during construction. There's a lot of strange stuff happened 15 years ago. So by having the full model, these guys are able to sit, over in that admin building and basically dive in and figure out what needs to happen and get their work orders arranged. They're able to pull dimensions and measurements. The pipe sizes are accurate. So, even if they're insulated, you need to know the insulation spec, but you can get the accurate dimension of the pipe and figure out what's going on from there. I mean, this is an area nobody wants to walk up to. It's a pretty long stair climb to get up to here. So having this level of detail for them to be able to really dig in there was important for them. And as they were going through the upgrades that they were making on these HRSGs, having all that information, knowing where the hangars are, it's again something we do. So we were able to help them with temporary hangar placement, but it's just right here. We're able to have basically those conversations over a Teams meeting, and nobody has to go on site. And nobody has to climb to the top of the HRSG again when it's 98 degrees in Florida and the cooling tower's just sitting there dumping more humidity on us. So that's been a pretty powerful tool for them. It goes throughout their whole plant. It picks up all their systems from the water intake all the way back to this is the Disney World ride for fish. They go all the way back through this pipe, and eventually, if you follow them all the way down, the fish eventually go back in the bay. So no fish harmed in the production of this electricity. Kyle, that's I could go on for hours. Is that the flavor you were looking for today? Is there?
Yeah, no, I think you did great. Thanks, Jason, for going through there. Again, questions are open. I will hit just a couple quick takeaways. So 4 things. 1, accurate data eliminates surprises. Value shows up in the planning and the execution phase. Most projects deliver a multiple on the cost of scanning alone. Jason even said it. It's basically free. It's a free service because it pays for itself in the savings. And then the real advantage is adopting a scan program across all your projects. So those are the 4 main things we wanted to hit on today. And let's open it up for questions. I see a couple in there now. Jason, you want to take that first question on
Sure.
safety? I know you're really passionate about safety. It's a big core value of ours. So I'll let you take that one.
It is. So that's good question. Kyle, different Kyle. So Kyle Nuss. So thank you. Safety qualifications for the techs that come on site. So we run a very tight safety program. Let's see, if you guys or any of your clients are on ISN Networld, we've been approved as of last Friday for RADS 360. So our score there was an 89%, which I was like, man, that I wish it was higher. He said, well, understand that you're in the top 1% of 9,000 contractors that serve heavy industry. So ISN Networld, if you're not familiar with it, is sort of a safety, insurance, and compliance clearinghouse for a lot of our large clients. So multinational building suppliers, paper, pulp paper, lumber, shingles, composites, insulation, those kind of things. probably our three largest clients for power are underneath there. So qualification wise, like and an onboarded safety tech is in safety training before we even issue them a pair of boots for about 32 hours. So, and that's not just the OSHA 30, that's separate. This is just kind of what we've built in being, I've been working in heavy industry since 90, I guess really since 96. So, oh my God, it's before the century. There's probably people on the phone that weren't born before then, but and it's I've worked in some of the most hazardous places in the country, and I've seen some pretty bad stuff. So, the training for us and safety compliance is huge. JSAs, our tailgates, our dailies, our near miss reporting. When RAVs what RAVs does, what I opened up with of being RAVs 360, RAVs ask you to send them a list of the people that go in the field, and they randomly just call them and they interview them for about 35 minutes. And they're looking for their safety knowledge. Not don't tell me what you were trained in. Tell me about it. Tell me how you put a safety harness on. Tell me about your MSHA experience. Or, what do you apply from new miner when you're on site? And they go pretty deep, and they go deep in the culture. And I guess that's what really keeps a lot of companies from reaching that upper echelon is they're going through the motions of training. And maybe their people are even retaining the training, but the culture's not there. And when our people were interviewed, they did mention we are rewarded for safety. We're rewarded for looking out for others, not just people on our team, but it's okay to go over to an iron worker and tell him that he's not doing something safe. And if you work in heavy industry, telling an iron worker or a boiler maker that they're doing that doesn't usually end well. But you know what? It's better than seeing something graphic in front of your eyes that you'll never get out of your space again. And I've been there and I've seen that, and that's what I convey to people when we bring them on. So as far as safety requirements by the site, those are going to vary. And so what we're not qualified in is nuclear. So we're talking about it, but we're not ready for nuclear yet. MSHA is in the works again. So we used to keep MSHA active when we were working in the cement plants in South Florida. We have kept all our MSHA logs and we've kept our MSHA presence, but we only have 2 people that are new miner safety trained right now. So I would call that like a gray area for MSHA, and neither of those guys are underground. So just to be transparent. So everybody else, we do a lot of online site specific training. And we do a lot of site-specific training on site when we get there. And those are typically, baked into the quotes when we're quoting our time. Of course, it's always helpful if you could share that with us. If we know that a guy's going to be spending 4 hours training to go onto a metadata center site, it's always nice to know because at least we can plan his schedule better if he's going to burn up a half day doing that. So,
Great, thanks, Jason.
Sure.
Or go ahead. Well, the
Yeah,
second
Jason, I was
question
gonna say one more quick thing just to that kind of goes along with safety and site access. If you could speak a little bit to just insurance requirements.
Sure. So right now, I think we're carrying, I think we're carrying 3 million GL and a 5 million umbrella and a 3 million E&O. So typically the only insurance issues we ever run into on scan and model will be people looking for like a $5 million professional liability policy, which really doesn't apply to what we're doing. So we'll typically ask for variance there. But I'd say 99.8% of the clients we talk to per year, we far exceed their insurance requirements. And we are able to name them as insured. We are able to adopt their subrogation language and everything else. So onboarding with a new client is usually very painless. We're very open to terms, terms across the industry are all over the place these days. Very, very infrequently do you see 30 days net anymore. We got one client that's at 180 days net. So But those are not blockers for us or showstoppers. Pretty healthy company and willing to work within whatever confines or boundaries you guys have commercially, both on the insurance side and on payment side.
Okay. And the last question I see on here is just more information about 3D modeling and engineering support for projects. If you want to talk about that a little bit.
Sure. So 3D modeling, I would say maybe 80% or not, maybe between 80 and 90% of the projects that we are asked to participate on will end up with modeling. And they're almost always asked for the modeling up front. And what we're able to do with modeling is some pretty high, what we'll call like basic modeling, which would be level of detail 300. That's sort of what you saw at the power plant that I showed, that big power plant. So even though we're showing valves and things like that, it's pretty granular and you can use it to check P&IDs. That would be kind of our base level of modeling. It's what most people pick. When we really, really need to dive in, if we are helping recreate a system or a machine or something like that, we can start upping that level of detail and bring it up to LOD 400 or 500 to where you're actually like seeing fittings and swedge locks and things like that on a robot or something like that. That's a very small percentage of our business. And it's not something we do every day, but we're very capable of it. It's just very expensive and not something that someone needs every day, but the capabilities are there. Typically what we'll see in the workflow is someone will bring us in for scanning. They'll have the model built, and where we used to say, like, we don't just deliver a hard drive with the scan on it, it becomes a very expensive paperweight. We also don't just deliver the 3D model. So what do you do with the 3D model now? And our delivery guys will stay with you through delivering the model and talking through, well, what's the next steps? Hopefully we've talked about that up front when we're scoping the job. But if we haven't, being able to say, okay, so you guys want to move these around. All right, it's not exactly how we built the model, but give us a couple of days, we'll fix it up, and then let me show you how to move things. And now you can move things in the model. If you want us to assist you in doing that, we can do that. We can update your floor plans. We can update your concept drawings. We can start to do like maybe some budgetary pre-bid drawings. So I mean, the engineering that's behind the scan and model division, that's as built. So the parent company is Essentium. That's the engineering company. All the way up through, like I showed in that crusher house. I mean, we stamp structural in, I think we're in 23 states right now that we can stamp in, maybe 24 right now. So we take these projects from, if you've got a concept and you think, hey, scanning would be a great idea to start this project, we've had this concept, we can track with you through the project life cycle. And will we do it for every project? No, there's things that we're not specialists in. We can help you find someone that is, and we can work really closely with them. So we can't do everything. But the stuff that we are good at, from mechanical, from structural, some civil work, I mean, it's kind of structural, but that type of stuff we can track with you guys and help you get projects from, maybe you're just delivering a piece of equipment and maybe that's what you've sold. And for your fan to be installed, we have to figure out how it's going to be arranged because it doesn't really fit in the space. And then we need to check, like, it's a bigger fan. Are we properly supporting it? And if we've rotated it 45 degrees, what have we done to the supports that were there before? Those are the type of things we can help you guys with. If you're delivering a new skid because that's what you represent or that's what your business sells, how is it going to fit up? Do we absolutely know that the nozzles coming out of the skid are going to match what's there? I know you got a drawing of it, somebody pulled a tape, but maybe we take a little further and we scan it, we model it, and we show your skid in place, and maybe we make a set of installation drawings for it, or maybe we help with an installation manual. I don't know how many of you are out in the field working with contractors these days, but the level of skilled trades continues to drop every year. And as our old guard skilled trades retire, we're starting to make picture books of how things come together. I used to think it was comical 10 years ago. It's almost required now. And these guys will just turn the page each day. That's their plan of the day. They're going to put in that part, and that part. they're going to demo this part, and this part. And nobody's really reading blueprints anymore. I mean, yes, they're still contractual, but people are really deep into these models. So kind of taking you all the way through. Yeah, we got the horsepower and the capacity to do it and the expertise and the experience to do it, but really just it kind of falls into where your appetite is and where we'll best serve you.
Thanks, Jason. One more question came in. Which softwares are compatible and common between receiving and delivering either the point cloud and or the 3D model shown on the screen?
Gotcha. Wow. This question's a moving target. So right now, I would encourage you guys to have a free version of Recap that lives on your computer. We run them on some pretty small laptops, so that Recap will consume the point cloud data. So Recap will show you what I was showing you. Oh, I don't have the screen right now, but Recap is what I was looking around at those 360 pictures in, and where I think you're going to see that move to is it's going to go up to the cloud. So we're already using it in the cloud. It's just that not everybody's licensed right now to use it in the cloud. It's not really free to use in the cloud. Autodesk wants a pound of flesh for you guys to see it. What we do for some of our clients, some of our reps clients, if they're going to be working in that project for 3 or 4 months, we just issue them licensing out of our pool. So we have an Autodesk pool of licenses. We just grant your project team 5 licenses. Say, hey, you guys good for like 4 or 5 months? Sure, and then it'll pull back after that. But that allows us to all collaborate online, and we're not bogged down with like, is my computer fast enough? Does IT let me load that software? Like everybody can pretty much get to a Chrome browser these days. And Autodesk Construction Cloud is whitelisted on. I've never come across a client that didn't have it whitelisted, or if they didn't, they whitelisted it for me within a couple of days. So I think that's where we're moving to. So 2 free local things. Like if you want to run it on your computer, look at Point Cloud and spherical pictures, those 360 pictures in Recap, and then look at 3D modeling in a free version of Navisworks. It's called Freedom. And you can download both of those programs for free. There's no cost to those. And as long as IT allows you guys to install those 2 programs will consume they'll be able to consume and help you visualize just about any project. So I mean, now if you're doing an entire power plant, they're going to get a little laggy. But you're working in a building or an area or portion of a plant, those are going to be easy things to run on your laptop and be able to share with people. But just know that that's all going to the cloud. Like what we can show in 3D on the cloud, I actually think it looks better on the cloud than it does even in the version that we run on the desktop. That's $3,200 a year. So that's definitely where it's going. There's not a whole lot being invested on the desktop stuff anymore. All the investment from Autodesk is up in the cloud.
Great, thanks.
Sure.
Now it looks like all of our questions, and so we will end it with that. And then again, the last Thursday every month, 11 a.m., Beyond the Scan. Each month will be different topics, different guests, different speakers. So keep an eye out for the next invitation coming in about 2 weeks. All right. Thanks, everyone.
Thank you.